Hello, everyone. Happy Friday. This is Alan Schimmel, DevOps.com, and you're here for another DevOps.com webinar. We've got a great webinar lined up today, courtesy of our good friends at Electric Cloud. And in keeping with the season, it's the 12 Days of DevOps. This is going to be a sort of an experts panel with tips and tricks that are going to help you with your DevOps and digital transformations over the next year and beyond. But now let me get to our storytellers for today's 12 Days of DevOps webinar. Neither of these gentlemen need really a big introduction for me. The handsome guy to the left is none other than Gary Gruver. Gary's the author of several best-selling books on the DevOps space. Starting and Scaling DevOps in the Enterprise is the latest. Gary's also led DevOps transformations at several Fortune 500, 100 kind of companies in tech and retail. And he spends most of his days helping organizations with their DevOps transformations. So Gary, welcome.
Thanks, Alan. Great to be here with DevOps.com again.
It's our pleasure to have you here. Joining Gary, equally as handsome on the right-hand side, is none other than the CTO of Electric Cloud himself, Anders Wallgren. Anders, welcome back. Looking forward to a great webinar.
Same here. Glad to be here, and it's always fun.
Okay, with that said, gentlemen, I'm going to turn it over to you.
All right. Just do kind of a quick intro here before we kind of kick off with the materials. We're going to go through 12 very, very practical tips on kind of what to do and how to get started. We're really starting on the left and moving all the way to the right. We talk a lot about shifting left these days, but we're going to go all the way through it today. So we got 12 days to get through. So we're gonna crank, and we're going to talk about how to transform your DevOps culture, or how to get a DevOps culture in place. Talk about increasing IT efficiency and delivering business value, because ultimately we need to do a little bit of that at least every day to get to keep doing what we're doing. So the 12 days of DevOps, and Gary, day number 1, I'll let you kick this one off.
All right, is it the 12 days or is it a 12-step program? I'm not sure, but either way, if we try to transform what we're going to do, a lot of times in large organizations, it's just hard to figure out where to start. And I recommend really, let's pick a deployment pipeline. And a deployment pipeline is code that has to be developed, qualified, and released as a system because it's coupled together. And ideally, if you've got loosely coupled systems, that's a team of 5, and those things can go pretty quickly. But in a lot of large organizations I work with, that's a much larger group of people and a different thing. But to really start to see the benefits and start to really get a feel for what this looks like, we really need to not just talk about it in generic ideas or generic approaches. We need to pick a specific deployment pipeline. And I waffle back and forth between whether that should be something small that gives you a chance to get used to the tools and the processes and different way to do it and seeing quick wins that way, or if it's something large. And a lot of times I tend to go large just because I think that's where your biggest waste and inefficiency is in an organization, because you can only get so inefficient with 5 people. If you want to see levels of inefficiency you can't even imagine, let's talk about trying to coordinate code development across 500 people. So I waffle. I think both places are good places to start, but I think your biggest opportunities for improvement are in the large, tightly coupled systems.
Yeah, I agree completely. I mean, I think what we run into all the time with our customers, and we're often dealing not with 500 people, but with 500 applications, and 10,000 people. It's hard. I mean, it's a trade-off to pick between, you want to make some progress, you want to show some wins, you want to kind of feel good about what you're doing, and so you're always tempted, I think, to pick something simple and small, and there's definitely merit and benefit in that. But on the flip side of that, if you do that, you may not really show much. So I think there is definitely merit to the argument of go a little bit big, not in terms of doing multiple things, but pick something that's a little bit complicated, maybe that touches on more than one technology stack, or that requires a little bit of coordination between different teams, or things like that, to make it interesting enough to show that this really does make a difference.
And if it doesn't have to be developed, qualified, and released as a system, just treat that as a different deployment pipeline. And you may want to get some teams going in parallel, but they shouldn't be on the same journey, and they don't need to be doing it the different way, because those package applications that have to work together have different problems.
Yeah, and every team is different. You know, everybody has different pain. You know, we could probably bucket them if we sat down and tried, but you know, it's definitely a case of, you know, find a pain point. You know, find the pebble in your shoe and remove it, basically. And if you can do that, then you know you get a lot of kind of positive feedback from that, and you can go off and do the next one and the next one and the next one, and eventually, you know, I've seen this happen several times where in the beginning of these kinds of transformations, nobody really wants to jump on the bandwagon till they see that it works and that it helps them. But then hopefully you have the problem, you know, that some of our customers run into, which is you want everybody wants to get on board once they see how you know how much easier things can be when you do this kind of stuff, and then you really have to figure out, you know, how to onboard efficiently and so on. But you got to start somewhere, and you know, start small. Don't start with everything. Don't try to boil the ocean, as they say.
And pick one. So we picked one. What do we do next?
Well, I think we should set up a continuous improvement culture. We're using the word CI here, both in terms of continuous integration, but also continuous improvement, which is very important.
Is that on your next slide? Because I haven't seen it in advance yet.
Should be. I did advance it. Maybe it's just making its way out there to where you are, hopefully.
Okay. Yeah, and this, in a lot of cases, I think it's important for that CI culture to pick the leaders that are going to start to sort of help coordinate this improvement across the organization. And this could be a head of dev, it could be a head of QA, it could be a head of ops, it could be a head of security, it could be somebody over all of those, depending on how it's there. So your slides are updated now. And really, and this could be part of the pipeline that you pick, is can you find a group of people that are willing to work together, that are excited and are engaged and want to do this? And are they willing to get into the details and start to work with organizations to start to understand what are the issues that are getting between them and effectively getting their work done, and seeing if they can be part of this continuous improvement journey? Because if you get the executives on board, you tend to be flying downwind. And if you don't get the executives on board that are over this, what you'll find is you're just heading into a headwind, and you'll see that you can make some progress from the bottoms up. But if you don't get their engagement, their alignment, their commitment to make these improvements, and if they don't believe they're going to help their business become more successful, you won't be able to drive the cultural changes, you won't be able to find the funding that you need, and you tend to lose momentum on your transformation in these types of instances.
Yeah, and I think it's important too to, you know, kind of keep your eyes on the prize, right? Because, you know, this is the kind of journey where you're going to have good days and bad days, and some days, you know, you're going to be doing more work than you used to before you started the transformation, right? And it's going to feel like you're not making progress. You know, there's going to be sort of, you know, the trough of disillusionment or local minima, you know, whatever geeky nerdy term you want to choose for it. And it's important to kind of, you know, keep your eyes on the fact that, you know, the quality of the daily work matters, but it's the improvement in the quality of the daily work, as they say, you know, kind of in the continuous improvement community, that really matters. You know, what we're doing today going to make a difference tomorrow, and is it going to make our lives easier? And that's really the goal that you have to keep in mind, because not every day is going to be about forward progress. You know, some days it's going to be about, well, we're swapping out the old way that we did it, and tomorrow we're going to start the new day, and nobody knows what the new thing is. And it's going to take a while to get familiar with it and get up to speed. And, you know, you can only learn so much up front. You know, at some point you just have to dive in and get your fingers dirty. And so it's all about the improvement.
And you need to get people to embrace these new ways of working. And, you know, if the leaders can pull from the organization what needs to get fixed and explain to them why we're going to be fixing it and why it's important that, you know, everybody changes how they're working to enable this to happen, and then markets the successes that you've had. You know, you need those things if you're going to be successful, and get the people to embrace new ways of working, because there will be bumps in the road. Yep.
People will have their cheese moved, and nobody likes that, so there better be a good reason for it. That's kind of part of what it's about. Are we ready to move on to day number 3, do you think?
Sure.
Let's do it since it took a while to do it last time. I'll preview it while it's making its way out to the world. But day number 3, is target an environment on the deployment pipeline. And Gary, I'll let you start on that one.
Yeah, and for me, the deployment pipeline is how does the code flow from a business idea all the way through to production? And the easiest way that I get that to occur is when I go into organizations, when we've talked about this set of applications is tightly coupled and goes through an integrated test environment, I'll talk about, okay, so we have this environment called production, and we have some dev developers on the left side, and we have production on the right side. What are the environments that this flows through on the way? Do you start with a pre-prod? Do you have a staging environment? Do you have a UAT environment? Do you have a QA environment? Do you have more than one dev environment? And then starting and scaling DevOps in enterprise, I really go over drawing out that deployment pipeline for the set of applications. It's kind of like in manufacturing, you start with a bill of material when you design a product, and then you break that down into its subcomponents. You figure out how you're going to build and assemble those. For software, the idea is taking your architecture, breaking it down into, the subset of components, and then talking about how you assemble those and build them up. And it goes from left of the developer's box all the way into production. And in this environment, we want to pick an environment to start understanding where the issues are and where the challenges are in the organization. And I think the best way to do that is look at the leaders that have agreed to lead this continuous improvement effort and go as far right on that deployment pipeline as you can, because if you've got influence over the broader thing, and you can change that, then you can really go in and go through and drive the changes and improvements. But if you only have influence to part way down in your component, you should start with that environment, because you're going to be able to make the changes and have the leverage to get things to happen.
Yeah, I think oftentimes we see where production environments are very off limits, right? And nobody anywhere near the left side of the schedule or of the process gets to touch them. That's always kind of very hands off. But that's one of many environments that you have to deploy to on your journey to production. And I think the advice is good in terms of if you can show that you're able to stand up and maintain, or hopefully not maintain, but just stand up and use and then tear down these kinds of environments, then once you get that going, once you get really good at that, then you can start to have the discussion of, hey, we probably want to extend this into pre-prod or staging or production, so that we're as nimble and agile there as we're showing, hopefully, that we are on the left side, because you really ought to, philosophically, I believe, you really ought to be using largely the same processes to deploy for production and for testing and for staging as you do for production, right? I mean, to me, it makes no sense to have kind of the practice squad practice all week without the team, and then the team goes in and plays the game on Sunday when they haven't practiced all week long. To me, that's how we do a lot of our production deployments. We kind of go in blind, and we throw a WAR file and a text file, over the transom and hope that the ops people can figure it out. That's no good. But at the same time, we're not going to be able to wander into the production environment and make big changes and hope that they work, right? So we have to prove that what we're trying to do is going to work in the lower environments, if you will, the non-production environment. So and make sure that we understand how those things are configured. And if they're manually configured, hopefully we can make a change to that over time, if not immediately, so that they get stood up and configured automatically, so that we're never in that kind of situation where the environment, and I put air quotes around the environment, is broken, because the environments shouldn't be fixed. It's kind of my personal philosophy. You throw them out and you recreate them, and hopefully get to where we have immutable environments where we deploy to them, we use them, and then we throw them away. So there's never an opportunity for them to get screwed up or to drift or any of those kinds of things. And I'm going to move us to number 4, and I'll read it off while it's making its way over the intertubes. But day number 4 is find stable automated tests. And that's a really important thing to do, obviously, and I'll let Gary kick that one off as well.
It didn't always start here, but after going through lots of clients and have different problems, I think the first step is to take that environment that you've targeted and take your automated tests and run all of them 20 times in a row and see if you get the same answer. If you've got a bunch that always fail, then take those and set them aside until you get the defect fixed so they can pass. If you've got a set that are toggling between pass and fail, you're not in a very good situation and you really can't use that for a signal at all. You're just going to end up frustrating developers if you ask them to try to keep those builds green, and it's stuff that's outside of their control. So, my very first step is finding a set of automated tests that are passing that you can run over and over again on an ongoing basis, because if you can't count on that as a stable signal, you can't use it to change how you're doing development. And what we're trying to do is we're trying to, instead of inspecting in quality with manual testing and entering defects, what we're trying to do is get the organization to be able to keep these automated tests running and passing in a way that they're fixing the defects without the overhead of entering the defects, and they're building quality in to get their code into the trunk. And you can do that with gated commits and going through that whole process, but you can't really start that process until you have some stable automated tests.
Yeah, I remember this great talk that Scott Prue from CSG gave a few years ago about how they introduced DevOps into their mainframe operation. And the very first thing they did, or one of the very first things they did, was they wrote 5 unit tests. That's all. And because they didn't have, many tests on that side of the house. And that immediately started paying off. They were immediately able to sort of, stop things in its tracks when there were problems. And, since then they've added to that test suite, obviously. But it is key, right? I mean, I think, if you're trying to change your processes and get a software pipeline going, and your tests are flaky, or the product has problems or things like that, then, I mean, it's a little bit like trying to level a picture on a boat in the middle of a storm. The boat isn't level at any point in time, so your chance of leveling that picture is near zero, right? So you got to get your boat into a stable harbor. If I'm going to push that analogy a little bit too far, and to where that if as Gary says, very simply, if you can't run those tests 20 times in a row and get exactly the same results, hopefully green, then focus on that, right? That has to be your first thing, because otherwise it's signal to noise ratio, right? You're going to be busy, thinking that your environment is broken when in fact it's your tests that are broken. So it's really, really key. And I've said this before, and I'll say it again: flaky tests are the devil. They waste a huge amount of time in organizations. If a test is intermittently failing, yes, that may well indicate a problem in the product, but more likely, and in my experience, most often, it's just a bad, poorly written test, right? It's got wait states in there, or it sleeps, or it's timing dependent, or things like that. Disable them, log a bug and disable them, and move on, because they're not helping you. They're hurting you, and they're not catching problems. They're just wasting time. So I think that's a pretty important thing to do. And while we kind of finish that up, I'm gonna switch over to day number 5 here, so that makes its way out. Day number 5 of the 12 Days of DevOps is ensure environment is stable, which of course is pretty related to the last one. But Gary, tell us about that.
Well, what I found is that when you get your tests that you think are good, you still need to run them over and over again to make sure your environment's stable. I've seen a lot of different organizations get stuck because there was maybe an intermittent F5 in the system that was timing out. Or I've seen people go in and their test environment, so one organization that had like 30,000 tests, and they automated tests, they only ran them once a week. And I was like, well, those are really good. Why don't you run them every day? And he goes, well, 40% of them time out. So I have to go through the process, and I have to go debug and rerun those and figure out which ones really find defects. And I said, well, why are they timing out? And he said, well, the environment's not large enough, so they're timing out. When you've been doing stuff manually, you can have an environment a certain size that works. When you really start to load it up with automated tests, that whole environment structure around it may not be stable enough to handle the automated tests. So really, once you have tests that you think are good, really load it up and see if you can always get the same answer out of those tests. And this is the same code, the same environment. Don't change anything, but just stress it as much as you can and go through and fix any of those issues with environment stability, because this is still back to that stable signal. If you don't have a stable signal, you really can't do anything to start changing how the environment, how the organization develops quality, and how you start building in quality in instead of inspecting it in.
Yeah, and a lot of the, some good practices for doing these kinds of things is to not configure environments manually, and not maintain them manually. To the greatest extent possible, use terraforming, Ansible, Chef, Puppet, Electric Flow, use something that sets up and configure these environments for you automatically so that it's push button and self-service to the greatest extent possible. That way, if there's a problem with an environment and you need to go fix it, you don't just go fix it on that one environment and then forget about the other 99, or don't go back and document what you did, or maybe even go back and document what you did, but people don't go back and read it and don't know. And so if you're following manual scripts to configure environments, you should stop doing that. You should make sure that all environment provisioning is on demand and automated, or at least automated if not on demand. Right. That's really key, because otherwise, your best practices are going to get ignored. Your best practices, nobody's going to know about them. And you go fix one environment, and there's 100 others that have the same problem that you don't go back and fix. So automating those things, doing the configuration management is pretty important. And have more than one of them. That's also a good thing. I've run into plenty of organizations where delays are introduced because people can't get access to the testing environment, because somebody else is using it, and you don't want to run simultaneous tests on there because they'll interfere with each other potentially. But if you have these things automated and you have the resources, then there's no reason why you can't stand up environments one after the other and use them simultaneously if your infrastructure supports it. So moving on to number 6. And number 6 is that ensure that your deployment is repeatable. And if you're seeing a trend here, if you're seeing a theme around repeatability, it's because there is one. Gary, take us away.
And this is where, you're trying to get something stable for the signal. And what I'm trying to do is step through one step at a time. We started with getting down to our stable tests, and then we ran it on the same environment over and over again. What we're doing is just changing one variable at a time and making sure that we're getting stability in the system. And so this is that same environment, that same version of the code, that same version of the test that we're passing in day 5. Can we take that same kind of code and deploy it the way we deploy it on an ongoing basis and get the same answer? And if you can't go through the process of getting the same answer after you do a deployment each and every time, you probably need to drive consistency into your deployment, and you need to get that resolved before you can go further in making improvements. And probably, when you're doing manual deployments, that's where you've got a real opportunity for issues and challenges. And it's a real good opportunity to automate the deployment of this stuff.
Yeah, the vast majority of delays and errors are introduced during handoffs and during manual processes. So this is definitely something where you want to think very strongly about taking all the manual phases and manual steps out of this. That can be scary in the beginning, right? I mean, do we not want human intervention for this kind of stuff? But computers tend to be pretty good at doing the same thing over and over and over when you tell them to. Humans, not so much. We forget things, we get distracted, the phone rings, we skip a step inadvertently, or we run the same thing twice. All of these things I think we've probably all done. All the way up to the big guys. Where the Googles, Amazon, Facebooks are not immune from fat fingering things when they don't automate, and we've seen that over the years as well. So I think it's you want to have confidence that when you push the button that everything will happen, and it'll happen the same time every time. And when it doesn't, you have to be kind of dogged and ruthless and tenacious in tracking down what the problem is and addressing it. You know, we've seen in our own systems here at Electric Cloud, seen, you know, bandwidth issues over I/O, bandwidth issues over networks, you know, bad NIC cards that are throwing, you know, trash onto the wires, and you know, it can be anything, right? I mean, you know, there's a reason we call them bugs. You know, if you look at the etymology of the word, a lot of times there's just physical issues that you need to address. You've got an overheating, you know, a storage system and it shuts down. You know, there's all kinds of things that can go wrong. But the more you automate things, the more you'll have a record of what went wrong and where, and you can be very rational and kind of going forward and making sure that it's repeatable and that you fix the process, fix the scripts, fix the, you know, whatever it is that you use for these things. Because this thing has to be second nature, right? It has to be, you just have to be able to pump these things out left, right, and center, and have them work, and have the problems that happen be the problems that you're looking for. You know, be the bugs in the system or the architectural issues or whatever it is that you're looking for, and not be problems that are due to your infrastructure or due to your processes or how you deploy the code, so on and so forth. And following closely onto that, number 7, ensure the environment creation is repeatable. I'm almost repeating myself when I say that, since I pretty much just said that. But you know, if you are doing manual environment creation, please stop. Manual environment creation will be the death of you. It is not scalable. When you have to go and you have to create, you know, 500 of these things or 1,000 of these things, doing them manually doesn't work. And maintaining a system that's been around for, you know, oh, that's our QA system, it's been around for 5 years, and we continue to patch it and string it along and so on. You really want to step back and look at automating environment creation. That really unlocks a lot of wasted time and allows you to focus on the important things, not the kind of infrastructure aspects of what you're trying to do.
Yeah, so this is, again, the next step, right? We started at, can we run the tests over and over? We got those stable. Can we do a deployment and run the tests and get that stable? Now can we get in an environment, then do a deployment, and then run the test and get a stable answer? And if you can get something repeatable, now you've got a signal that you can ask your organizations to start to respond to. And this process of going through and doing these things and fixing them is going to start helping you right away, because people in your organization are fighting with these on an ongoing basis. It's just not that visible to you because they're doing it at a very low frequency. And if we're going to do it at a higher frequency and really try to pull these two things together, make it easier to triage in smaller batches, we need this stable signal, and we need to keep going on that way.
Yeah, and you know, and the fact that it doesn't work, or the fact that it works at all when it's not repeatable and automated and so on, is generally due to, you know, heroic efforts on the part of employees. You know, staying late, coming in over the weekends, you know, missing family time, all of that kind of stuff to get these things up and configured, because it can be time consuming, and especially if you have to triage and fix things. And then, you know, you want to stay away from the kind of, oh, I fixed it, you know, and somebody gets it going again, but now you don't know what they did. You know, you have no idea. You have no idea what the learning is from that. Is that something, you know, is that something that was easy to fix? Is it something only that person knows how to do? Is it something that we got to put back into the process? As good and laudable as it is that people step in and do those kinds of things, it's actually counterproductive in the long run to have these kinds of heroic efforts, you know, where people emerge from the data center, you know, all sooty and say, all right, it's working, I fixed it, you know. That's great, that's nice, but you really want to get to the point where it just works every time. And you know, as we've often said, you know, if something hurts in DevOps, you need to do it more frequently and in smaller batch sizes. Because if you want to get to the point where you just don't do this once a quarter, once every 6 months, once a year, or even once a month, these things can't take days, and they can't even take hours. They have to be done in minutes. And typically, once you automate them, they're very fast. You know, most of the delays introduced here are just, you know, humans typing and those kinds of things. And once you get things going, it's not unusual for, you know, for our customers to have self-service access to environments in 5 minutes, right? As long as you have the right permissions, as long as everything is set up correctly and all of those things, you've got your environment 5 minutes after you ask for it. And that allows people to get their job done much more quickly. And one of the, you know, most fundamental types of delays that are introduced into software processes in our experience, and we've done, you know, a couple of non-scientific surveys. I would just want to say they're non-scientific, but for anywhere from 12 to 20 hours a week spent waiting on things, waiting on environments, waiting on builds, waiting on tests, those kinds of things. And you got to take those wait states out because people are not being as productive then when they're having to context switch and go back and forth, not to mention the waste of time in general. But once you get that kind of stuff done, go ahead, Gary.
Well, I'm just saying, getting this stable signal can take months. My last webinar, there was a case study, and it took probably 18 months in a large organization to get a lot of these things resolved. But once you get that, you're really ready for this next step, which is really starting to see the benefits of what you created. And where you start that cultural transformation is by asking everybody in the development organization to respond to this signal. And now we're asking them to build quality in instead of waiting and responding to defects and inspecting in quality later. So we're asking them to change how they develop such that they can bring code in on a regular basis without breaking the existing functionality. And this is going to take some time. And similar to what you said with Scott Proof, start with 5, start with 7 tests and get them used to the idea. But you really can't do that until you have a stable signal. And now that they have a stable signal, you can start with a few tests. And if you want to know what tests to start with, go to your manual QA people and say, what things do you see that make it completely useless for you to be testing an environment? It's so bad, it's the functionality so broken, you shouldn't have it. And start to add those 5 tests in here and require your development organization to keep those tests running with every single check-in. And do that, and then over time add some more tests. But you need to add those tests at a rate that the organization can be successful in bringing them in and handling them. But start by job one is keeping the bill green and not allowing it to be broken on a daily basis.
And everything leading up to this, everything leading up to day 8, is all in service of being able to basically say to people, look, this is running right now. And it's stable. We can deploy over and over and over, and it works. We've got a few tests, and really in this scenario, less is more. Right? You don't need and probably don't want 10,000 tests in the scenario. 5, 10, 15, 20. These are smoke tests, and I don't know if this is officially the etymology of the phrase smoke test, but I think of it as we put this thing together, we're going to plug it into the wall outlet, and if smoke doesn't come out of it, then okay, we keep testing it. But if smoke comes out of it as soon as we plug it into the electrical mains, then we got problems, and that's really what you want to get to. But you have to have your house in order a little bit before you can then start to ask the rest of the organization to not break it or to respond and fix immediately when it does break. If you get to number 8, if you get to day number 8, and you want to start the start the transformation, and you haven't done your homework and you haven't done the previous 7 days, you're going to have problems, right? Because the first time something breaks, and it's because there was a problem in the deployment script, or there was a problem in the environment, and it wasn't the code issue, right? Now you're the boy who cried wolf or the girl who cried wolf, and that's not a situation you want to be in, right? You want the smoke tests to be uncovering problems in the product, not problems in the process, not problems in the environment, and so on and so forth, right? So it's important because we're really on day number 8 we're pivoting. Right, we're pivoting away from this is us doing this, and now we're gonna ask other organizations and other individuals to sign up to this, and to treat this very seriously. That if there's a problem here, we jump on it. We drop everything else and we jump on it because it's important. And that really is part of the the cultural transformation.
And the reason we step back and do that slowly is because what I found is that organizations jump to step 8 too soon, and you tend to have an insurrection from the developers because you're slowing them down and you're breaking their ability to get stuff done based on stuff that you haven't fixed that's outside of their control. So I really try to make sure that I go through that part.
Yeah, and I'll give you a very specific example from my own history of that kind of scenario where we were doing some performance testing, and we got a report back saying, oh, the performance is terrible. This new change is drastically reduced the performance. But it turned out that the system that the performance test was being run on had its network interface misconfigured. It was running at 10 megabits, not at a gigabit. So the network performance was drastically affected by that. And that was because the system was set up manually. It wasn't configured automatically. And at that point, and to some extent since then, there's been mistrust as a result of that. Every time, certain people do performance testing, it's okay, did you make sure that the NIC card is configured correctly? Nowadays it's more of a joke than anything else. But that was that was one of those scenarios where a lot of time and effort were wasted chasing our tails because we were sloppy in setting up an environment. So and you lose credibility when that happens, and it's hard to get that credibility back. It's hard to earn, but it's easy to lose.
And then the other thing that I find is we've got them and we've asked them to keep these tests passing on an ongoing way. And what we want to do is make it easy to get the right behavior out of the developer. So what are the things that we can make triage easy for them as we're gating code and making sure it can't go through? When they get a build failure, I've seen organizations do things like they send a package out that includes the automated tests that failed, all the debug and log information. Actually, they've gone through the logs and scrubbed out the errors so it's easier. So go talk to the developers about what do they do when they go to debug and triage, and are there things that we can automate pulling that information together so it's really easy for them to do the right behaviors and they're more productive in terms of triaging. So once they've gotten used to keeping these builds green and these tests passing when they fail, go ask them what they're doing and how they're approaching it and what they need for debug and triage, and seeing if there's any other way that you can pull that information together for them automatically so that it's just straightforward and easy for them to do the right thing.
Yeah, and if you've ever said or heard the phrase, it worked on my machine, then this is for you, right? This is the kind of scenario where, okay, it broke, it broke during our automated testing, but hey, it works on my laptop. So what you want to do in those kinds of scenarios maybe is, so let's say that you're automatically creating and standing up the environments that you're running these tests in, right? And let's say that you can have as many of these environments as you want. You tear them down when you're done. In that kind of scenario, if you have a failure during testing, you could put that environment aside, right? Preserve it so that whichever engineer is going to go do the triage and figure this out can go look at the actual environment where it failed and maybe figure out, oh, hey, look, you've got the memory config wrong, or there's not enough shared memory, or whatever the scenario may be, and they don't have to go try to reproduce it on their local system, which may or may not work because they're sort of innately setting it up the right way, and kind of don't remember the fact that, hey, there's a step missing in the configuration that I didn't tell anyone about. So the more you automate environments, the more environments are, as they say, cattle, not pets. Then you can, if you're in the habit of, after a successful test run, you tear down the environment and you free those resources up, then you can just as easily, if a test fails, keep that environment and just set up another environment for the next test and leave that environment around so somebody can go log in and triage to it. Or better yet, as Gary alluded to, provide all the information necessary to be able to do that. And that can be tricky because even in lower environments, sometimes developers simply don't have physical access or login access to these environments, and it can be tricky to just go find a log file. And in that case, tooling can help you with that, to be able to, pull log files back, include them, push them around, those kinds of things. So this is an opportunity to, let the environment work for you, and make sure that that developers have access to where it failed, because it's not always relevant, and it's often a waste of time to try to reproduce the problem somewhere else. Because if it is a configuration issue, they probably aren't going to configure it incorrectly. They're just going to do it correct every time, and then we're wasting and losing more and more time as a result of that. So into the double digits. Day number 10. Increased gating at the speeding of dev. So Gary, what do we mean by that?
Well, we've gotten them used to responding to these 5 tests. We've gotten it efficient from the triage. Now you can start building in more and more quality by raising the gate, by adding tests to get it more stable on an ongoing basis as you do that. But you want to do that at a rate that the dev organization can be successful at keeping these builds green on an ongoing basis and going through that process. So it's a balancing act. If you start with 5 tests and you get good and then you add 5,000 and nobody can get a green build, you're going to have an insurrection again. So this is a cultural transformation that needs to be gradual, and you need to start increasing the barriers and the gates for quality at a rate that the organization can handle.
Yeah, and I think it's, this is where, again, I think, day number 8 really is a very bright line. You don't want to get to day 8 unless you're confident in that everything is working the way you want it to, because starting now, kind of on day 10, you're going to start to pile on more tests, and again, yeah, you don't want to dump 5,000 tests in there on day number 10 just because your first 5 works, right? And that, as unintuitive as it is for us to say, hey, don't run a lot of tests, you really do want to ramp this up, because if the quality of your tests are at all suspect, then that's going to be very painful, and that is going to lead to either the insurrection as Gary refers to it, but also, I mean, it could just be that people stop paying attention to it, right? And they don't fix things, or they don't, they're not as careful as they ought to be, and those kinds of things. And really, you want to get into the culture where we take this seriously. I mean, we don't want to break things, and when things break, we have to go back and look and say, look, where should we have caught this? What is the fastest, cheapest, least amount of effort way that we could have caught this? Is there a unit test that we could have written to catch this and just do it during, figure these problems out during CI, continuous integration? Or is this the kind of thing where, oh, it only happens on, when we run on Oracle because the SQL dialect is slightly different than it is on SQL Server, and that makes it more of an integration or system test, right? But you always, when you have these problems, want to kind of figure out, okay, how far left can I push that? How cheap can I make finding this problem earlier? And once you get into that mode, because you don't want to write everything as a system test. System tests are slow. They tend to happen late in the process, and you always want to be thinking about, how fast and how cheap could I have caught this problem in the process. And once you get into that mode, it's easier to make progress, and you have less chance of, well, shit, the builds are always broken anyway, so I don't care. I don't know. I mean, I've heard that phrase hundreds of times. Well, our builds are always broken, so it doesn't matter if I check in flaky code because I can't tell anyway. Getting yourself dug out of that hole is difficult. Falling back into it is easy. So vigilance is something that you have to have around this, and this is why these things are cultural transformations, right? They're not just follow these steps, and if you follow these steps faithfully, you'll get there, right? This requires a mindset, and it requires diligence and really paying attention to these things, and that's difficult. It is not easy, and it takes time.
And it gets us right up to day 11, where
yeah.
we really started as far right as we could, because at our level of influence, keeping that environment stable and working good is going to have the biggest impact on the broadest number of people. And now we're starting to figure out, now what is the causes of these, and can we catch them sooner? Can we catch them upstream? Can we catch them closer to the developer so they can learn real time? And we start taking what we've done in this environment and moving it to the left, starting with the dev components that are causing most of the challenges and the issues in the organization.
And this is where analytics can start to help you a little bit, because you can start to look at is there a particular component in the code that's causing issues frequently? Maybe that needs a little bit of TLC or some more resources on it. Is there a particular type of environment that we're always having problems with? Other steps that people are skipping because they're too slow or take too long, and they want to get home and have dinner with the kids. There's all kinds of reasons why things don't get caught. But most frequently it's just because we didn't write a unit test, we didn't write a simple test as we could. I think we've probably all heard or seen kind of the graph of how the cost of fixing a software issue goes up exponentially the further to the right we go. The cheapest place to fix a bug is on the whiteboard, before you even write the code, get the architecture right, and so on. But after that, then it's, unit tests are the cheapest. Integration tests are much more expensive. System tests are hideously expensive. Anything that's a manual test, anything that requires human eyeballs on it, are incredibly expensive and slow. I mean, a unit test that runs in a millisecond compared to a system test that takes me, an hour to configure, and then I have to, I have to run it and do it and look at the results, and 4 hours later I know the answer. That is way, way more expensive, and it's going to happen far less frequently. And so is, in that sense, is a very bad candidate for a smoke test, right? So it's every time there's a problem, no matter where the problem is in the pipeline, wherever you discover it, you should always be asking the question, how could we have caught this further left, right? What is a cheaper way for us to discover this problem? And sometimes it just, it means, we got to write, more robust unit tests, or sometimes it means that, well, the way that we're configuring the environments when we do unit tests is a little bit irregular, and everybody just runs them on their own machines, or, those kinds of things. And oftentimes you uncover, kind of more structural things that you may have to go fix. But once you get into this kind of cadence of, where, and everybody kind of knows this around the Electric Cloud office, like if I get brought in on a bug, at some point during the meeting, I'm going to ask the question, how far left could we have caught this, right? Could we have written a unit test to catch this? And so that just becomes part of the process after a while, that you get used to, and you don't like how expensive it is to fix things, in system testing or integration testing, or God forbid, when the customer has their hands on the functionality, right? Or once it's an on-premise product and you can't even do an update anymore without, rolling out a new version of the code or something like that. Then, you really get motivated to make sure that these things get fixed, as far to the left as possible. But there's good news too, because once you've done all of these things and gotten good at them, you get to spend day number 12 having fun. If your, version of fun means, break out the spiked eggnog, which, in my case, I don't love eggnog, but I'll drink it. And we may have lost Gary there, I suppose.
No, I'm here. I'm not the huge eggnog guy either, but if you can really get this up and you can start shifting left, it is an opportunity to celebrate in whatever way is appropriate for you.
Yeah, and I think that, the thing to do is kind of, look back on the progression, as the days are kind of laid out here, because, when you face those difficult days, when people are complaining, rightfully or wrongfully, or there's a little bit of an insurrection, or people are frustrated, or you're frustrated, very often, if you kind of go back a little bit and look past, into, day 6, day 7, day 5, day 4, oftentimes you'll see that the problem that you're having today is because you didn't do something all the way and correctly and thoroughly back in the day, or you've just discovered another area where you need to go back and address things, right? It's not that you were negligent back then, it may be that you just didn't know about it. But oftentimes, it's not that you've gotten to, day 11 or day 12 and, it's not going to work. It's, well, we discovered another area where we have to run through the process. And, running through the process in the sense means go back to day 1, make sure you've got an environment set up in CI and that it's reliable, and you have tests that you can run repeatedly that without failing, and you've got environments that you can deploy to repeatedly without failing, and all of those things. And if at any point those things are no longer true, then, it's like chutes and ladders. You got to run down the chute again and climb back up the ladder. And do it again, and make sure that that environment is stable, that the deployment is stable, that those tests are running and are not flaky, and all of those kinds of things. Because this process does work, right? I've seen dozens, in fact hundreds of organizations do this and do this well. It is not easy. It takes time. This is not something you do in a week or even a month. For large organizations with hundreds or thousands of developers and hundreds or thousands of products, these are months-long or years-long transformations, and it's not always, a step forward every day. Sometimes you have to take a step back and say, all right, we forgot something. We didn't do that one right. We've got to go back and do it. But hopefully, once you get that done, you will start to see the cadences improve, the quality improve, the throughput improve, and you can't sit around and drink spiked eggnog.
Yeah, but you really need to get the stability first, and that's why it seems like basics, but I've seen so many people go past the basics and end up with an unstable system and a failed DevOps experience. So hopefully this slow way of walking through it has helped, and maybe we have some questions that we could answer before we run out of time.
Yeah.
Yes, we do, guys. And before we even get to the questions, though, it almost goes without saying, but Gary, Anders, you guys just rock. So thank you so much for sharing with us and giving our audience kind of your knowledge that was not gained without real t-shirts and scars to prove it, right? So let's go with our first question. What is the difference between, oh, I just got an extra one there. What is the difference between patch deploying and code release?
It's funny. In some ways, they're not really different at all, right? Because in both cases, you're going to touch, for the sake of the answering the question, you're going to touch your production system. So in that sense, you want to go through and do everything you always do. And now, clearly what's happening is if you're doing a big release versus a small patch, the amount of change that's coming in is different. So the risk is higher, and this is why we always talk in the DevOps and Agile community about small batch sizes, right? And instead of doing the big bang release with 1,000 commits every month, do smaller daily or weekly commits, because when something goes wrong, and something is eventually going to go wrong, right? It's no good designing all of this stuff just for the happy path, right? You have to design it for troubleshooting and for deciding what to do when things go wrong. But from that perspective, they aren't really different, except that you're throwing a lot more changes into a release, and so there's a lot more risk. So you really want to go through the motions and go through the same process for each one. Now, you may have different standards, right? If, let's say, I'll take this to the logical extreme. Let's say that you're fixing a typo on the website versus you're releasing a brand new feature, right? Fixing a typo on the website can probably go through less governance in terms of approvals and so on, or faster governance at least. Whereas if you're going to roll out a whole new feature, you're probably going to have a bit more governance and testing and so on around that, but it still ought to go through the same basic pipeline.
Absolutely. And Anders, I almost think that it's nomenclature, a throwback to an earlier time. I mean, I remember in my days when we, running companies, when we'd release code, we would often have multiple builds with the same version number, just a different build number. And the build number, referenced maybe patches, where the version number referenced releases, even if they were minor point releases, 5.12 versus 5.13. But you may have three different 5.13s, different builds of 5.13. And, I think one of the good things about DevOps is with repositories and a checked in code, we don't see that craziness that we did back then.
Yeah, it is a little bit more governed, and a little bit more rational.
Well, with version control's a lot has had, version control in many ways is one of the overlooked assets or big things that DevOps has really kind of bolstered, and it's really helped with some of those things. Anyway, let's move on to the next one. How do monitoring, AI, machine learning factor into feedback loops?
I think it's another form of testing or feedback that you can give. And if operations wants things to work well in operations, they ought to work on putting their monitoring and everything that they would use in operations in the deployment pipeline and moving it further and left and asking the organization to respond to it. And if it really helps make the debug and triage more efficient, then you'll find that if they start using it, we'll start putting in the capabilities and the links that you need to use the monitoring effectively and use it to triage effectively. But if you only use it in production, they don't ever get a chance to see it. It's not very likely that they're going to invest in it in a way that'll make your life easier in production.
Yeah, I think there's a lot of interesting things going on in the space right now with machine learning and AI, and we've done a bunch of work around that with our DevOps foresight and so on. But let me be pretty frank about this. Artificial intelligence and machine learning It's not going to help you fix up a screwed up process or help you fix up an environment problem or any of those kinds of things. You've got to do the blocking and tackling. You've got to get the fundamentals right. There's no artificial intelligence or machine learning in the world that's going to help you in that scenario if you're not already good at it. It's really more for, I would call it an advanced use case, right? We've got 1,000 applications. We've got a lot of different teams. We're trying to figure out how to get our velocity up and those kinds of things. That's where you can start to get insights from those things. But if you're not today able to, without machine learning, without AI, release, build, test, qualify, release software without AI and machine learning isn't going to make you better at that. It isn't. If that's your hope and that's going to be the silver bullet to clean everything up for you, you're going to be sorely disappointed. You got to get the fundamentals right, and then those kinds of things can help you as you're looking to figure out, okay, what's the next stage? How do we make this even better? You've got to get the fundamentals right. Don't worry, don't bother, don't even think about machine learning or AI until you get your normal intelligence and normal learning under control. Then you can look to the machine and artificial version.
Yep, excellent, guys. We have a bunch more questions, and I'd love to hit them, but we're already at the top of the hour. Anders, Gary will get you these questions to your emails, and perhaps we can answer them offline. A special thank you to Gary, Starting and Scaling DevOps in the Enterprise, his newest book. Guys, are we going to announce, or we've got to go tabulate who the winners are for the hashtag contest, correct?
I suspect so, yeah.
Yeah. All right. Attendees will get a copy of the book. And attendees, I apologize. I realized I had audio problems when I first got on. We've got to call into our wonderful service provider, one of our wonderful service providers here, and we'll hopefully rectify that. But I do apologize. It's the internet. Sometimes it works and sometimes it doesn't. Anyway, Anders, Gary, thank you to both of you and to all of our listeners today. A happy holidays to you all. Hopefully we'll see you on another webinar soon. And again, special thanks to our friends at Electric Cloud for presenting just another killer learning experience. Thanks, everyone. This is Alan Schimmel, DevOps.com. Have a great day.
And happy green holiday to everybody.
All righty. Bye-bye.